This presentation will cover the basics of the Shimadzu TOC-V and TN instrument. So this instrument has two components to it. The TOC-V component measures carbon and the TN component measures nitrogen. Both are for aqueous samples only, and we consider the carbon and the nitrogen to be dissolved because they have to go through a filter before they come onto this instrument. So there's a picture down at the bottom there of the instrument itself. The left housing is for the carbon unit, and the small housing on the right is the TN unit. What we measure on this instrument includes dissolved organic carbon, total dissolved carbon, dissolved inorganic carbon. You can measure volatile organic carbon, also known as purgeable organic carbon, but that's a less common application, as well as total dissolved nitrogen. So let's delve deeper into how this instrument measures carbon and nitrogen. So if we want to measure total carbon, the sample is injected from its sample tube into a syringe, and the syringe is then going to put an allotted amount of this sample onto a combustion column. This column is filled with an oxidation catalyst, and it's heated between 680 and 720 degrees Celsius. What happens is the carbon, when it enters this oxidation catalyst combustion tube, it becomes oxidized and it forms CO2. So now the CO2 is pushed through the instrument with the carrier gas, which in this case is purified air. It passes through a dehumidifier and a halogen scrubber to the detector. In this case, the detector is an NDIR detector, which stands for non-dispersive infrared. So it's actually measuring the infrared wavelength signal of CO2. And the signal actually forms a peak, and the peak area corresponds directly to concentration of carbon. Conversely, if you just want to measure organic carbon in your sample, what you need to do is pre-acidify with hydrochloric acid, which means acidify your sample before you put it on the instrument. What this does is the HCl reacts with the inorganic carbon in the sample and turns that inorganic carbon into CO2. So then when your sample is sparged on the syringe in the instrument, you're getting rid of that CO2 that was previously inorganic carbon, and all you're left with is the organic carbon in the sample, and then that is injected onto the combustion column. Same way as total carbon after that. Still red on the NDIR and everything. So then if you want to look at just measuring inorganic carbon, what happens there is the instrument will uptake your sample into a syringe, and in the syringe it actually mixes in a known volume of hydrochloric acid and it sparges. And so then what's happening is you're sparging off that inorganic carbon into CO2, and then it sends that CO2 directly to the NDIR detector. It completely bypasses the combustion column at this point. If we take a look at how nitrogen is measured, the nitrogen in the sample is injected onto the exact same combustion column alongside the carbon in the sample. It's being oxidized to NO, and then it gets sent through a separate pathway to the ozone catalyst where it's converted to NO2. Now, while it's being converted to NO2, it emits light. This reaction actually emits a light quanta, and that's what the detector on the TN side is measuring, is the light quanta emitted by the reaction of NO to NO2. This is called a chemiluminescence detector, and there's a nice little diagram down there that shows you what that would look like. So examples of nitrogen sources: could be free ammonia, ammonium, nitrite, nitrate, as well as all the organic compounds that can be converted. So, like I said, this instrument measures aqueous samples. I would say 90% of those samples are water samples. They come through for various types of water monitoring, whether that be for algae growth and eutrophication, carbon cycle monitoring in waterways, streams, rivers, lakes, you name it, acidification of waterways in the various forms of inorganic carbon species, wastewater, whether that be from like farm runoff or from mines, and then also people have done studies on how well they can push the carbon dioxide uptake for their algae media. So we've measured carbon rates for them. And then a kind of interesting application, you can actually do soil extracts with potassium sulfate, and you can measure the microbial carbon cycle that way. So really interesting applications that this instrument can handle.